Hello, dear students. I want to speak a little bit about molecular shape. Molecular shapes. What are what are they and why are so important? Well, the shape of a molecule plays a large part in determining its properties and reactivities. So if we know the shape of a molecule, we can predict if, for example, its polarity. We can predict shapes by examining the Lewis structure or orientation of electron pairs. The electron pairs arrange themselves to minimize electrical repulsion. Don't forget about this. This is very important. Remember that two electrons repels one to the other. So they try to be as far as possible in the space. In order to predict the molecular shape, we assume the valence electrons repel each other. Remember that the valence electrons are the outermost electrons and are the ones that are important in chemistry. Therefore, the molecule adopts whichever three-dimensional geometry minimized this repulsion. The electron pairs arrange themselves as far as possible from each other. We call this process valence shell electron pair repulsion, the VSEPR theory. Why this theory is so important? Well, because gives a specific shape due to the number of bonded and non-bonded electron pairs in a molecule, and tells us the actual three-dimensional structure of a molecule. Again, in bonding, electron pairs want to be as far away from each other as possible. Remember that. Let's see, for example, if you have two electron pairs, well, they try to be as far as possible, and the angle is 180 degrees. So the molecule is, or the electron pair geometry is linear. When we have three electron pairs, for example, 1, 2, 3, where the bonding angle will be 120 degrees. And the molecule will be, or the electron pair geometry will be trigonal planar. Here in this case, for 4 electron pairs, then it will be tetrahedral. Let's see an example how the theory works. For example, we draw the Lewis structure for the molecule. Example, SiF4. The central atom is silicon, and then you locate the fluorines in the sides of the silicon. That is the central atom. Then you count the number of bonding pairs. In this case, you have 1, 2, 3, 4 bonding pair for the central atoms. And the central atoms doesn't have lone pairs. Then look at this. 4 bonding pairs and 0 lone pairs on the central atom. Then you rearrange the rest of the atoms so that they are as far as possible. For example, fluorine, the 4 fluorines will be as far as possible. In this case, this structure looks like a tetrahedral. What is the difference between geometry and shape? The electron pair geometry. We determine the geometry only looking at the electrons. All the atoms that obey the octet rule and have single bonds have the same tetrahedral-like geometry. But the shape or molecule structure depends on the positions of the atoms, and we ignore lone pairs in the shape. For example, in this case of carbon dioxide, the structure will be linear. In the case of sulfur, this will be bent. In the case of SO3, is trigonal planar. In the case of NF3, is trigonal pyramidal, and so on. You can see the different shapes of the molecule according with the theory that we are studying. Let's predict the model by this theory. For example, we know that this molecule has 2 pairs of electrons, of bonding pairs, but there are not non-bonding pairs, so the molecule is linear. Example, CO2. In this case, you have 3 bonding pairs and 0 non-bonding pairs. In this case, the molecule will be trigonal planar. But you have the case that you have 3 electron pairs, but 2 of them are bonding and 1 is not bonding, like the case of NO2, where these 2 electrons are not bonding. So the molecule in this case doesn't take into account these 2 electrons, and we see that the shape is bent. It's the same structure of the water molecule. When you have 4 electron pairs, you can have 1, 3, 2, 3 cases. If you have no bonding pairs, the molecule will be tetrahedral. If you have 1 no bonding pair, then it will be trigonal pyramid. But if you have 2 non-bonding pairs, then it will be bent. Then the number of non-bonding pairs in the center atom, remember that, is very important in order to know the shape of the molecule. Then, what is the effect of non-bonding electrons on bonds, on bond angles? Multiple bonds on bond angles. Well, look at this. In this case, all the bonds are single. Then it is a tetrahedral, and this is the angle for a tetrahedral. But when you have a non-bonding pair of electrons, In the central atom, this is the angle. And then this is a pyramidal structure. In this case, that you have two non-bonding pairs of electrons in the central atom. Remember, always in the central atom, this is the angle and the structure will be band. Since electrons in a bond are attracted by two nuclei, they do not repel as much as lone pairs. Therefore, the bond angle decreases as the number of lone pairs increase. Take into account this thing. What is the effect of non-bonding electrons and multiple bonds on bond angles? Well, when you have a double bond, this angle will be bigger than the angle between two single bonds. Well, the dipole moments on polyatomic molecules is very important in order to determine the polarity of the molecule. For example, in this case, the two atoms have different polarity, different um, at, electronegativity. So the dipole moment goes in the direction of the more electronegative atom. And this molecule is polar. In this case, the molecule has angles, and then these dipoles cannot be canceled up, and the molecule is also polar. But look at this. In this case, the angles are the same. So the dipole moment of this molecule is 0 because these dipole moments cancel with the rest. The sum of the three dipole moments is 0. So the molecule is non-polar. In this case, happens the same. The molecule is non-polar. But if one of the dipole moments is different, then the molecule is polar. I hope that now you have a is more clear, or is clear for you, this concept of the shape of the molecule and how can it be very important in order to determine if the molecule is polar or non-polar. Thanks for watching this video, and if you have any question, please send me an email and I will answer you as soon as possible. Thank you very much and see you soon.